Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem palindrome partitioning. So here we are given a string S and we have to partition this string S such that every substring of the partition is a palindrome. Return all the possible palindrome partitioning of S. So we are just given a string S and we have to return all the possible palindrome partitions. So what are palindrome partitions? So we have to partition the string in such a way that if we that that every partition that every substring of that partition is a palindrome. So in the example 1 we can see that this AAB is given, and if this A B is given and we partition the string two times, first partition here and second partition here, so we can see the substrings which we have got A and B is, we can see that every substring here A and B are palindrome. Similarly, if if we partition just here, we can see this string is both substrings which we are getting, this AA and this B, both are palindrome. So we have to just, we are given this uh, string S and we have to partition anywhere such that anywhere we have to do any number of partitions anywhere such that here or here, such that every part of the partitions or every substring, I should say, like here or anywhere, every substring is a palindrome. So we have to just return all the possible palindrome partitioning of S. So now how we can solve this? So we can see that we have options here, that we can we are given this string A and B, and we have options here to to apply partition here, to apply or not apply, here to apply or not apply, here to apply or not apply. So we are having options. So options lead to the concept of picking or non-picking, like something we do in recursion, and here we have to return all possible palindromes. So we have to generate that what we say, that generate the set which will contain the strings where all the strings substrings are palindrome. So we can think here of recursion plus backtracking, so that we can check every possible partitions, that if I apply partition here and not rest of the places, or if I apply partition here and not rest of the places. So we have option that either to apply partitioning or not, either to apply or not, either to apply or not. So we have to check all the possibilities. So we should try here recursion and backtracking here. So I am taking the same example SAAB, example 1. So I have drawn the recursion tree and I will just explain that we have options, that either we should take this A or this B to partition. All right, so first of all my I will be here and I will ask, what if I take this current string in my, take this current character in my string, let's say, and and then I check rest of these strings. Alright, so if I have option to take this or not take this. So how will I check I have to take? So I will take this ith character only if and only if this is a palindrome. So if I take this A, if I take this A, so my current string will become A, and now I have taken this here if only when this current substring is a palindrome. So we can see this A is a palindrome. So now we can happily check for other characters, rest of the string. So I have happily checked this character A. Now I can happily check for rest of the string. So my rest of the string is left with AB. So I have applied partition here after A. Now again I have the same thing. I am given the string AB, and now I have to check whether where I can apply partitioning. So I have options either to apply here. So here, first of all, I would like to apply partition after A, after the first character. So my initial I will be here. So again I will run a for loop. So first of all I will check for this A, and now I will check if this current character is a palindrome. So yes, we can see that A is a palindrome. So now I will apply partition and can check for the rest of the string, that is left is B. If this current character was not a palindrome, I would say that now there is no need to go further, because we are not getting palindrome. All right, so we should not apply partition here, and we can go and check for the other ones. All right, to take whole as a string now. So first of all, I am saying that here A is a, I have applied partition at the first character A. So I have applied partition here. Now my rest of the string left is B. So now I will check, first of all I will check, is this B a palindrome? So yes, this B is a palindrome, and now I can just go further, and my index I will go out of bound, and I will we can see that string is over, and we have applied partitioning to partitioning such that whole string is covered and every substring is a palindrome. So we will return here, we will store in a data structure this string. All right, so now backtracking. So here also I have checked for this I. Now I will move forward. And now here I have just checked that if I apply partition here at the first character, now I will take this second character also. I will take this A both as a one string, and now I will apply partition here, because I have to check every possibility. So first I will try to apply partitioning here, then I will take this both characters A and I will apply partition here, then I will take all the three characters A, B, and then I will apply partitioning here. So if I apply partitioning here, and the rest of the string left will be B, and I will check is this is a palindrome, then we can go and apply partition. We can store this in our current set, and I will go and apply partitioning here, and again I will say that check the current string, check the next character. Here my next character will not be accessible because it has gone out of bound. So I will say that now if I have reached the base case, that is out of the bound, I can say that I have covered all the characters, and I have covered all the characters only if I have applied partitioning such that every substring is a palindrome. So I can see I can easily store this answer, store this current string, current partition, I should say, in our data structure, that this we have got here. All the substrings, these two A and B, are palindrome. Now I will take this AAB as whole, and now first of all I will check that is this AAB is a palindrome or not. We can see this is not a palindrome, so we will just return from here. So we can see that we are just doing one thing, that we are applying partition everywhere. So we are applying partition everywhere. So first of all, we are trying to apply partition here, and we are checking possibilities for after applying this partition here. So after applying partition after the first character A, so now after applying this partition in the first character, I will check all the possibilities that after applying this partition at the after the first character, what could be other possibilities that if I apply, I will be left with this string. I will try to apply here also, and similarly, and now I will try to apply take this AA as whole string, and I will try to check for the rest of this string. So, and then again I will take this whole string all and check that is this a palindrome, then I will go further, or I will return. So we can see that we are just checking every possibilities by first applying partition after every characters, and then in each partition applying after every character, we are going deeper into the recursion tree and just checking if I've applied here, this is saved, and now my left of the rest of the string is AB, and now I will check that where I can apply partition. Can I apply partition here? Can I apply partition here? So, but one thing we have to keep in mind that we can apply partition here after a string if and only if the current string is a palindrome. So this A was palindrome, that's why I applied partition here and checked afterwards. I applied here partition because this whole AA was a palindrome. I didn't moved ahead because I didn't apply partition here because this AAB was not palindrome. So there is no need to go move further. So this was just the logic that we are using recursion and backtracking. We are just storing the current strings we have got when we reach base case, and we are just checking every possibilities that where I can apply partitioning or not. So if I go and implement this, so first of all I would like to store the size of this string as n, and now I will store a current string vector of string as current, where I will be storing the answers, and I will store a resultant 2D vector also. So now I will just call my solve function to fill up the resultant vector. So I will first send the index number 1. We can see that we are checking all the possibilities for applying the partition. So first I will use a for loop for every case. So if I'm applying partition here, then here, and then here, so that's why I'm using a for loop. So there is also a recursive way to solve, but this approach is very transparent that we are using for loop. So solve function was there, current subset, current vector I was sending, resultant I was sending, string I was sending, and size I was sending. Then at last I will just return the resultant. So now first of all I will complete this function solve, and here I am passing index and then this current vector and then this resultant vector, and then I'm passing string s, and then I'm passing integer n, and I should pass all with references because this will save my time complexity also. And now what I said, I will write the base case that if my index is greater than equal to n, it is out of bound, then I can say that I can store this result. I can store this into result. So after storing, I will return, and then what I said, I will use a for loop for iterating to all the possibilities, iterating to the array, iterating to the string to apply partition. So there is another method also to not use for loop and write the pure recursion, but here I am using for loop because it is very intuitive, that first of all I am applying partition here and then checking for the rest of the string, then applying partition here, then applying here. So I'm using a for loop directly. So for loop is starting from where? Index. First of all, index was I was passing was 0, and I will iterate from the current index to the rightmost. Now I should be less than n, and I will increment I. And now first of all, before applying partition, I will first check that the current palindrome is palindrome or not. I mean, suppose my I is here, suppose my I is at this position where I is written, suppose my I is here, and before moving ahead, before applying this partition, first of all I will check if from the index, that is my starting 0, to the current I is a palindrome or not. So I will send the string, I will send the starting, that is my index, and my ending, that is I, is palindrome or not. And if this is palindrome, then I will, what I will do, I will first of all if this is a palindrome, then I will store this into my current array, current vector of strings. So I will store this. So what I will store, I have to store from if I am storing this a, so what so from index, from here to here, I am storing this substring a. So I will write as dot substr, and substr takes what, first the index, so starting index is index, and then the length is its length is 2, so the length is simply I minus index plus 1, I minus index plus 1. And yes, this I will push back into my current vector, and then I will say that now go and check for further possibilities. So I will just send I plus 1 here, and current and resultant string and size n. And now after coming back, after checking all the possibilities of this, I will just say that remove this from my current subset. Now I will go and create a check for new one. Alright, so I have checked this I have checked this possibility. Now I will remove this partition and I will check this as a whole. So now I will remove the current that I pushed back. Now again for loop will continue. I will be here, and this will take the string as a whole, check for palindrome, and again if it is palindrome, then it will go deeper. Alright, so this will fill my resultant vector, and yes, I have to write the palindrome function or not, palindrome function also. So this is boolean, this will be boolean, so palindrome. So what it is taking, so it is taking just the string s and the starting and the ending index. Now we all know how to write palindrome function. If left is less than right, I will check that if s of l is not equal to s of r, if the left index is not equal to the right index, I will return false, else I will move both the left and right indexes forward and backward respectively, and at last if nothing returns false, then I will return true. So this, if I run this and check that if we are able to pass sample test cases or not, and if I submit this and check if we are able to pass all the test cases or not, so we can see that we have solved this problem successfully now. And if I talk about the time and space complexity, so we can see that we are checking for checking every possibilities. So at every index I have two possibilities, either to apply partition or not. And if there are total n elements, so I have uh, total possibility of 2 to the power n checks. All right. So and every 2 to the power n checks, I am what I'm doing, I'm checking for palindrome. All right, so I'm checking for palindrome also, and i'm I'm using this substring, I'm just using this substr function also, and I'm just pushing back the current vector also. So if if the average length of every if the average length of every subset, if I am getting here, is let's say k, then this will be 2 to the power n into k, and the palindrome function, this will be taking the what complexity it will be taking. So let's say at max whole string goes and it checks for whether it is palindrome or not. So whole string size is n, so palindrome's time complexity is n by 2. So now approximately we can say that the time complexity is big O of 2 to the power n into k, where k is the average length of every every vector of string which we have formed, which we are storing into the resultant 2D vector, and into n by 2. All right, n by 2 is the time complexity for palindrome. Now space complexity, if I talk about, so we are just taking extra space for storing the result. So for storing the result, if the average uh, length of every vector is k, and if the average length of every vector is k, and there are, let's say, total x combinations, so that space complexity will be big O of k into x. All right, so this was all about this problem. I hope you understood. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.